Okay, guys, we are going to talk about two-way frequency tables now. You might not have seen these before, but they're super, super easy. They look harder than they are, I promise. They're like, meh, easy peasy. So a two-way frequency table summarizes something called bivariate categorical data. Remember, bivariate means two, at least two variables. Categorical, obviously, being talking about categories. Now, there are going to be some different terms we're going to talk about. One of them is probability, or you might also see it as relative frequency. Probability just means how many times could something possibly happen, right? The number of favorable outcomes divided by the total number of outcomes. When we see the word joint frequency, we're talking about the number that matches both of the conditions. And that does make sense because joint, right? Think about together means it's going to satisfy both conditions. And then the last type you're going to see is marginal frequency. It's the total number for one specific category. Okay. So I'm going to show you some examples here. And again, I promise you it's way easier than it looks. So let's take a look at example one. In example one, it says 80 students each study one science. Complete the two-way table and answer the questions below. Now, here's how this works. If I'm looking at biology, right? So these ones here are the columns, right? Going up and down. If I look at biology, it says there are 18 females that take the biology course. Right now, I don't know how many females take chemistry. I don't know how many females take physics, but I do know in total that 47 females, right, are how many I have over here in total for my sample. Now, I can do a little bit of math here that's super easy peasy because what I see is in total, I have 80 people and I already have 47 of the 80 people are female. Well, to figure out how many males there are, I'm just going to subtract these two numbers, right? I'm going to take 80 and then I'm going to subtract the 47. And when I do that, I get there are 33 males, right? So 47 females, 33 males. In total, I have 80 people part of this sample. So I can kind of do that throughout to help me out. So I see, for example, if I look at physics, I don't know how many females there are, but I know 19 of them are male. And in total, I'm looking down the physics. In total, I have 33. So essentially, I'm going to take these two numbers, 19 and 33, I'm going to subtract them, and that's going to give me how many females there are. So 14 females, right? Because 14 plus 19 gives me the 33. Now, I don't have another, it's like hard. I can't go straight to biology. I can't go straight to chemistry, right? Because I've got too many blanks. However, I can go across this way. If I look at the rows now, for females, I know I have 18 females in biology, 14 in physics, and I know in total I have 47. So to figure out how many are left over in chemistry, I'm going to take biology and physics. I'm going to take those numbers. I'm going to subtract them from 47. So I'm going to do 47 minus, I'm going to subtract both biology and physics. And so in total, I will get 15. Okay, now I can go straight down for chemistry. 15 plus what number is going to give me 21? Well, that's 6. And then now I'm going to look across at male. And like, you don't have to go in the same order as me right now, but this is what's making the most sense for me. For males, I can figure out how many are in biology by subtracting the chemistry and physics from the total of 33. So that'll give me 8. And then if I go down for biology, 18 females and 8 males give me a total of 26. So, excuse me, you've just completed a two-way table. Now we're going to answer the questions. Okay. So let's do a different color now. All right. What is the probability or relative frequency that a student is female and studies physics. So probability again means the number of favorable outcomes over the total number of outcomes. So it's favorable over the total number. Okay, so favorable would be a student that's both female and studies physics. So I'm going to come back up to my chart here. I'm going to look for female that studies physics, and I see that is 14 total girls, right? That would be the favorable number. But the total is how many people in overall do I have? And I've got 80 people in total that are part of this study. So 14 out of 80 gives me, probability wise, it is 0.175. So that's it as a probability. But if it does ask you for a frequency, if it's looking for a percent, to make this into a percent, right, I just move the decimal place over 2 places to the right. So this is about 17.5% is my final answer. Okay. I know it looks bad. I mean, it's like not that bad. You just got to be really careful about what you're reading. Okay. What is the joint frequency that a student is male and studies biology? Okay. So joint frequency means the number that matches both conditions. Okay, so it matches both conditions. Okay, so if I look at my box here, or my table, excuse me, how many males study biology? So males studying biology, 8. That's it. So my joint frequency, how many times is it happening? 8. 8 students, 8 males is my joint frequency. Okay, next one. What is the marginal frequency of biology? Okay, trying to change colors. Okay, marginal frequency means the total number for that one category. Okay, regardless of another variable, it's just the total number for one category. So if I'm looking at biology from my work here, right, here's biology. I just want to know the total amount of students taking biology. That's 26. So my total number of students is 26. Okay. What is the probability of a student studying chemistry? Okay, so again, probability means number of favorable outcomes over total. So favorable over total. What's the probability of a student studying chemistry? So if it was favorable, they did study chemistry, right? How many do I have in total that are studying chemistry? That's 21 students. And then how many people did is my sample size, how many people were there in total? There were 80 people. So my probability, I guess I should really put is about, because this is not exact, right? Is about 0.2625 as a probability. But if I want to make that into a percent, right, I just move the decimal 2 to the right. It's about 26.25%. So the hardest part here is just making sure you're reading the question really carefully, because I think this part is like not that bad. To me, I just kind of view it as a puzzle, okay? All right, so now we'll try one on our without any numbers given to us. So there are 150 children at summer camp and 71 signed up for swimming. There are a total of 62 children that signed up for canoeing, and 28 of them also signed up for swimming. So we're going to fill in some of those numbers that we see. Ooh, excuse me. Okay. So 150 children total. So that is right over here. Here's my big total. All right. I'm going to check it because I did that one. 71 signed up for swimming. So 71 said they're going to swim in total. Don't know about if they're canoeing or not. I just know in total I've got 71. Okay, did this one. There are a total of 62 children that signed up for canoeing. So 62 signed up for canoeing. That's down here. And 28 of these 62 also signed up for swimming. So that is 28 right here. Also signed up for swimming. So now this is where it's like my puzzle kind of comes in. And this is where I'm doing a little bit of like adding and subtracting. So if I look at the column for canoes, right, I see 28 people sign up for swimming. I can figure out how many did not want to swim because my total for canoeing is 62. So if I subtract 28 from 62, I'm going to get 34. So that's my no swim total here. And now, again, you don't have to go in the same order, but I'm going to look at swimming. I'm going to say, okay, 28 are doing canoeing. How many more are not canoeing so that I get a total of 71? So again, just going to subtract those two. I get 43. I'm going to go down for the totals now. 71 plus what number gets me to 150? That would be 79. I'm going to the right. 62 plus what number here gets me to 150? So that is 88. Right, those two add up to 150. And again, I'm just like doing a little bit of subtraction here, right? So this part is easy peasy. So already, boom, look at that. We constructed a two-way table to summarize the data. Okay. Always, always, always you're going to have totals. So make sure if it doesn't give you totals that you write in the totals yourself. Okay. So you'll always have your data and then the totals on the rows and columns that are listed there. Okay. Next part. Determine and interpret the marginal frequency of canoeing and not canoeing. Okay, so if we go back to what is marginal frequency, that means total number per category. Okay, marginal frequency. Think about literally, it means in the margins, right? So that is your total total number for that category. Okay, so if I look at canoeing, right, I'm looking at the total number of people that canoed, that's 62. So I can say my my marginal frequency of canoeing, I've got 62 that are canoeing. It's like a weird word, canoe. Okay, and then if I look for the total number that are not canoeing, I've got 88. So when it says interpret, right, it's just saying like, what does that mean? So that means out of the total 150 kids in total, right, out of the 150 kids, 62 of them decided to canoe and 88 decided to not canoe. Ooh, that's it. You've interpreted. That's the whole thing. So easy. Last one. Determine and interpret the joint frequency of not canoeing and not swimming. So remember, joint frequency means together, right? All in this together. Okay, so joint frequency of not canoeing and not swimming means, right, which one satisfies both of those conditions. So it needs to satisfy both conditions. So I really should only get one number because how many kids are not canoeing and not swimming? So I come up here, not canoeing and not swimming. Those two meet right here at 45, right? So not canoeing, not swimming. So out of my 150 kids, there were a total of 45 kids are not canoeing, and are not swimming because they're Little weenies with like little little babies. Okay, that's it. And you have now finished creating two-way frequency tables. So take some time right now. There's going to be a couple of different practice problems that are going to show you how to continue doing some two-way frequencies. But again, important to remember that joint frequency means both conditions are together, joint. Marginal frequency means just the total for that category. And then probability or relative frequency means how many things are favorable over your total amount of people. Okay, so maybe take a moment, write those formulas down so you have them, and then go ahead and give those other practice problems a try. And hopefully you understood, because you can't ask me questions. Also, can't turn this off. Okay, great. All right, have a great day.